Hello everyone, and welcome to a Projects Minisode. I guess that's what we'll call it. Today, as the title suggests, I'll be explaining how to roll coal and some of the principles behind that and the steps that I took to achieve this goal. Alright, so the first thing I'd like to say is that simply by doing the steps that I'm going to point out here, you're not going to get a horsepower increase. Some people say, oh, you just put a resistor on this sensor or whatever and you're going to get more power. I'm not saying that's completely incorrect. There are lots of different engines that operate in many different ways, but that is not what I'm talking about here. You might get a small power increase right at the bottom end as you roll into it because you're going to have more responsiveness. That's all we're gaining here. We're gaining responsiveness. Alright, with that out of the way, what happens when you nail your foot to the floor? Well, your ECM is going to read that I'm pretty close to 5 volts or whatever the throttle position is. It's going to read 100%. Okay, so now your ECM is going to say, all right, pour or add this much fuel, however much fuel is it's supposed to add for whatever rating your engine is. This engine is a 5 1/4, 525 horse, 1850 torque. So it's going to open up the fuel or the pulse width, whatever you want to call it, to that parameter. Okay, now that parameter is going to go, and this is just a rough kind of explanation, visualization. It's very basic. This is the way it was explained to me. It could be somewhat incorrect, but this is the way I have understood it, and that's how I'm telling you. Alright, so then from there it's going to go to a set of tables. One of the tables may say, hey, wait, we can't pour that much fuel because we're only at 1,000 RPMs. Another one might say, hey, we're at very high elevation, we can't add that much fuel, or whatever's going to go on. But what we're focusing on today
is the boost table. And the way it works is whatever fuel it's requesting will go to that table and it will say, hey, we can't pour that much fuel, we only have 5 pounds of boost.
So it'll cut the fuel back way down to however much they've set it for at that boost rating, or that boost pressure. Now, as it adds more and more fuel, the pressure will come up and it'll continue to add more and more fuel until you're wide open boost and full fuel. What we're doing here today is we're tricking the MAP sensor, the manifold absolute pressure sensor, back here on the back of the intake manifold here on this N14 Select Plus, and we are going to be sending the ECM a false reading of boost where it thinks, hey, we have plenty of boost, and it allows full fuel to be injected. Alright, so my original plan was, okay, here you see the plug-in that hooks into the MAP sensor. I have two of these quick couplers, these quick splicers that I've spliced. Okay, we have the 5 volt hot coming from the ECM. We have the ground on the other side. Down here at the bottom, you can see we have the output that would go to the ECM. All this MAP sensor is a potentiometer, and that's a voltage regulator. So it sees, in this particular one, it sees basically no boost. It'll send a 0.5 volt back. ECM knows, okay, we're at no boost. Now, if you unplug it, you have 0 volts and it throws a code. It knows there's an open circuit or something's not right. Now, once again, what I've done is I've taken this tiny potentiometer, this adjustable one here, and of course one side gets ground, the other side is hot, and then it has the output, which is then going up that set of wires into the cab and to a switch on the dash. Now, for some strange reason, I don't know why this is, I'm quite baffled by this. What was happening was the 3 volts or whatever this pot was pushing out to the switch, and then of course back into the output of this plug-in to that would go to the ECM. Well, like I said, you'd get a 0.5 volt when this was plugged in at no boost. Now you'd flip that switch on, and here at the potentiometer it would show, yeah, 3 volts. Whereas unfortunately once you'd plug it back into here, for some reason the wire going to the ECM would only show that same 0.5 volt. Almost as if, and I don't know, like I said, I'm not sure why, almost as if the current or something else from this actual MAP sensor was overriding what the pot was telling to the ECM. So the only time that worked was when you'd actually unplug the MAP sensor and then click the switch to on. You of course, you turn the switch off, and now it's reading 0 volts and throwing code, and it's not happy. And strangely enough, also when I just had that switch flipped up, the Jake brakes wouldn't work, and then you flip it back down to off, which is open circuit. It wasn't really happy either. It would wait a couple seconds to turn the Jakes on. So that wasn't all that fun. So now what I've done, and once again, I'm not sure, lots of people, they talk about resistors. I'm not 100% sure how that works. So I just use this potentiometer where I could adjust it. And once again, I'm not sure why it didn't work just overriding the signal from the map sensor with the one from the potentiometer from the switch. So what I unfortunately had to do now was, what I've done is, of course, the pot is getting 5 volt hot, ground, and the output is going to the cab, as well as the output from the actual map sensor, boost sensor, is also going into the cab. So what I've done, alright, so I plugged the sensor back in. Now, what I've done is I've got this 3-way switch. Center is off, of course, it's got 6 terminals. This wire right here comes from the potentiometer, and when I have the switch flipped up, it will then send that voltage to this terminal, and that wire just goes back to the ECM connection to then give the ECM the false reading that we have plenty of boost, so it'll pour fuel and roll black smoke, because that's what we're trying for here. And also, well, I'll get into that more later. And on this side, I have this wire, which just goes from the output of the map sensor, and when I have this switch flipped down, it will then send that output back to that same wire spliced together here that goes to the ECM, to where it will read correctly from the map sensor, and everything will be all fine. It'll operate normally as it was designed to. So we won't have any weird codes or anything like that. And this way we're also isolating the two to where one won't override the other, and that's a weird issue that I was having. Now, I want to show you the voltage, because when I was doing this, there was not a whole lot of information on this, and it could be different depending on your engine and the way things are set up. All these map sensors can run on different scales, to where the voltage that I'm using may not be the voltage you're using, but this is the way I've done it. And this Kevin Rutherford scan gauge here has been very helpful to figure out what is actually, what the ECM is actually reading. So first I'll show you what the voltage is. Flip the key on. Alright, so there's that 1/2 volt from the map sensor. And we'll have to try and see if I can wiggle it up there. Alright. So, and there's a 2.9 volts, almost 3 volts, coming from the potentiometer. Now, what that will show, if I can operate this correctly, we'll start that up. We're going to go up to then show, I need a second now, it's a little slow sometimes, 28 pounds of boost. And we can go back to the stock, normal, and we're at 0. And the thing turned itself off. Alright, now I'll put this switch back into the center. And now it's an open circuit, and the check engine light comes on. So that's how that works. And what I was going to say earlier was that we're not just trying to get black smoke out of this. There's also another element. Well, I was going to mention the mechanicals, but they also had AFCs and Android valves and junk to try and keep the smoke down. And I'd honestly rather screw the pump instead of mess around with wires, tricking the ECM and screwing with sensors and junk like that. But to get, basically one other thing I'm trying to do is get closer to an old mechanical or a well-built mechanical, souped up whatever, that will roll coal, and then drive it so it doesn't. Just the extra challenge, trying to introduce the extra skill of driving a truck in such a way where it'll do whatever you ask it to. It'll smoke like crazy and blot out the entire sky or whatever. That's a little extreme, isn't it? And make insane amounts of horsepower, but also blow up in 3 minutes if you just mash your foot to the floor. Trying to introduce some skill and, I guess, more control over the whole system, and I guess trying to master oneself a little bit better, if that's a way to put it. Now what I'm going to do is I'm going to get this pile of wires and try and cover them up with some heat shrink and waterproof it a little bit, or make it a little bit water resistant, so it'll have I guess a little bit longer service life, hanging out here under the hood with all the spray and whatever else you get here and the elements and whatnot. And then we're going to take her for a spin and see what she does. Alright, we're taking her for a drive. I got a load on. Got the switch up. See what she does. You couldn't see that too well. You can see part of the cloud. So it's working just like it's supposed to do. We put it back down on normal. Let's grab another gear. And not a whole lot. A lot more sluggish. So we got the responsiveness, we got the smoke that we wanted. So I think we're going to be good to go. And now, one of the things, if you actually will leave it on, the switch up the whole time, where it's always reading 28 or some odd pounds boost, you'll actually get a code, at least on this engine, for the boost. Heck, I can't remember what it is, but it's something like the boost pressure invalid, intermittent, or incorrect, something like that. So this way we can keep everything happy and still get the extra responsiveness and smoke and the responsibility like we wanted, or at least I wanted. Well guys, I hope this helped you understand some of the systems involved.
And I hope it gave you a good starting point if you were looking to whip up your own device. Now, one thing I forgot to mention was that the results I got were actually kind of sedate compared to what I'm told some other people have seen. What I'm getting at is that you need to, if you do this, you need to be aware of fuel knock. I mean, it's really, really bad for your engine. These big diesels, they can handle a lot of abuse, but that'll still kill your engine in a big hurry if you get to the point where it's detonating like that with the fuel knock and whatnot. So I thank you all guys for hanging out and taking a look and checking this out. Thanks for watching, in other words, and until next time, have a good one.